session we will study about the numerical related to function. There is a question number 3. Determine the domain range of the following function. Look at here in these sub questions. You see all the questions are rational expression. Mention the P over Q form. It is x plus 7 over x minus 5 here. X square minus 1 over x minus 1 here. In third, you see f of x is equal to mod of x minus 1 over x minus 3. So let us see how we solve this sort of rational expressions functions question. So we start with sub question 1 here. So we get the solution for this. First question, we are saying that f of x is equal to x plus 7 over x minus 5, because this is given to us. Now therefore, first I would like to explain something. We know that the rational number can be expressed in the form of P over Q, where the condition is Q is not equal to 0. Here the denominator, the polynomial which is in denominator, is should not be equal to 0. X minus 5 should not be equal to 0. So therefore x minus 5, just I change the color, x minus 5 should not equal to 0. Therefore x should not equal to 5. We transfer this 5 to right side, it will be positive. Now the domain, thus the domain is any real number except 5. So this is the domain of this function. Now we have to find out the range of this sort of rational function. We see how we get the range of this sort of rational function. We know that f of x is equal to y. So we put here y, putting here y is equal to x plus 7 over x minus 5. Now I cross multiply this x minus 5 to left side. So here I get y into x minus 5 is equal to x plus 7. Now you see, we simplify this. I multiply this y inside this bracket. So I get xy minus 5y is equal to x plus 7. Now implies to, I am taking x to left side and other terms to y side. So it is xy minus x is equal to 5y plus 7, because 5y which is negative, it will transfer to right side and get positive. Now we see that implies to x we are taking common here in left side, so it is y minus 1 which is equal to 5y plus 7, implies to x is equal to now 5y plus 7 over y minus 1. So now we have again get a rational function. Here you see in denominator y minus 1, because we know that the rational function denominator should not be equal to 0. So y minus 1 is not equal to 0. So because we know that y minus 1, which is the denominator of this rational function, it should not be equal to 0. Therefore y should not equal to 1. It means the range of this function thus the range of this function we could write that the range, thus the range is, we could write that the range is any real number except 1. So this is the range of this function. How it should be the range? Because in the domain we know that if x is equal to 5, then it would become infinite, not defined. But here you see, if we put here 1 instead of y, because we have the function this instead of y, because we have found out the range y is not equal to 1. If we put instead of y 1, we see what happens. If we put here 1, we get x plus 7 over x minus 5. We have here, we are putting y is equal to 1 because we know that y is not equal to 1. So we see why it is so. So 1 into x minus 5 is equal to x plus 7, or you see here the x will eliminate to each other. So there is no x, minus 5 is not equal to plus 7, so the x should not, so the y should not equal to 1 for range. So this is the way how to find out the domain and range of a rational function. F of x is equal to x square minus 1 over x minus 1. We know already that the domain, for domain or the range, whatever we have to find out, the denominator should not equal to 0. So here, therefore, the same procedure we are following here, x minus 1 should not equal to 0, therefore x should not equal to 1. So that thus the domain is any real number except 1 or minus 1. This is the domain. Now we have to find out the range. The same procedure we will follow as we have followed in the previous question. Now for range, we'll put that function y is equal to x square minus 1 over x minus 1, because we have this function. Now we will factorize this numerator. So y is equal to x plus 1 multiplied by x minus 1 over x minus 1. Because you know that the x square minus 1, we have used here identity a square minus b square is equal to a plus b into a minus b. We have used here. Now look at here, in the numerator and denominator x minus 1 which is common, it will eliminate to each other. Therefore y is equal to x plus 1 we have, but we know that x is not equal to 1, because we have just found out the domain of this function, which is not all real number except 1. So if we put here instead of x1, so this equal sign will convert into not equal. So we put here, therefore y is not equal to 1 plus 1. We are putting 1 because x is not equal to 1, therefore it is not equal to y. Also if we put x is equal to 1, so now y is not equal to 2. So thus the range is any real number except 2. Thus the range is any real number except 2. So this is the range of this function. Now if you put 2 instead of y, what will happen? You can check it out as we have checked in our previous question. Third part of this question number 3, the third sub question. We have f of x which is equal to mod of x minus 3 over mod of x minus 3. For domain, for domain, we know that the denominator should not be equal to 0 because x minus 3 should not equal to 0, therefore x is not equal to 3. So the domain is any real number except 3. The domain is any real number except 3. Now for range, because we know that f of x is equal to mod of x minus 3 over x minus 3, or we could say that the x minus 3 in numerator, you see the mod of x minus 3, it means either it may be negative or positive both. So if it is non-negative, if x minus 3 is non-negative, then x minus 3 is greater than equal to 0, and we get here x is greater than equal to 3. We are getting this thing, x is greater than equal to 3. Or we know that, here I explain again something, mod of x minus 3 is equal to x minus 3, which is positive. If we are taking this positive, so here x is greater than 3 we have. Now I put this thing here instead of therefore I put here f of x is equal to x minus 3 over x minus 3, because this condition we have taken here. So we will get here 1 because these both will eliminate to each other and we get here 1 now, cut each other. Now if x minus 3 is negative, if x minus 3 is negative, then you know that x minus 3 is smaller than 0 and therefore x is smaller than 3. You get this. So here you see mod of x minus 3 is equal to negative of x minus 3, negative. This. So we put f of x is equal to minus x minus 3 over x minus 3. See, again we get here, we cut these two, both are the same, and we get here minus 1. So we are getting 1 and minus 1 here, as the range of f is the set of consisting only two numbers, minus 1 and 1. So thus the range is consisting only two numbers, 1 and minus 1. These two numbers we get here. So in this way we could find out the domain and range of the modulus function. And this is the rational modulus function we have, or if you have to find the range and domain of this sort of function, we could find out through this way.